Okay, so today we're diving into. Oh, hey, our listener wants to join in. What's up?
Hey, sorry to interrupt. So, what's the novelty of this paper? And can we go through the main takeaway with the key points? Because we only have about 5 minutes.
Hey there, no worries at all about interrupting.
We're happy you chimed in.
The paper we're discussing is called Bootstrapping Latent Thought Models.
You can find it as a preprint on ArcSieve number 2503.18866V1.
And absolutely, let's zoom in on the main idea for you.
So the core takeaway about making AI language models learn more efficiently.
Think of it like this. When humans write, there's a lot of thinking that goes on behind the scenes.
Right, all that background knowledge and reasoning.
This paper explores how we can train AI to kind of infer those hidden thoughts.
These latent thoughts, as they call them, can then be used to improve learning.
It's like the AI is learning not just from the final text, but also from the potential thought process.
This can be especially helpful when there isn't a huge amount of training data available.
So the big point is that by modeling these underlying thoughts, we can get more out of the data we have.
It's about quality over just sheer quantity.
Does that give you a good overview in your time crunch?
We can definitely elaborate on any of those points if you have a quick question.
Okay, so now that we've covered that for our listener,
Yeah, let's get back to the core concept.
we were saying that the text we read is like a compressed form of richer thought.
Exactly, like a snapshot of the final result.
And this research is looking at how to unlock that hidden information.
These latent thoughts hold crucial reasoning paths.
So it's about understanding the how and why behind the text.
And the paper digs into how to model and infer these latent thoughts.
They even used math problems as a key way to test this out.
Because math has that clear step-by-step logic.
And they saw some pretty impressive results when they used these latent thoughts.
The performance on math problems jumped quite a bit.
It really highlights the power of this approach for reasoning tasks.
And they even found it outperformed other methods like chain of thought in some cases.
So it's not just about adding more steps, but about that deeper understanding.
And to figure out these latent thoughts, they use this Bolte algorithm.
Which uses that expectation maximization framework.
It's a cycle of the model guessing thoughts and then improving based on those guesses.
So the model kind of learns to think more effectively over time.
Exactly. And the results show it can really boost performance.
It's like that reasoning to learn idea in action.
Where better reasoning leads to better understanding.
And this whole process can even happen without constantly needing new data.
It's about getting smarter with the data you already have.
And when it comes to actually using these models,
They can leverage these latent thoughts during prediction,
even using those thought prompts in the latent space.
guiding the model's internal reasoning process.
And their research shows this latent chain of thought can be very effective.
Even more so than regular text-based chain of thought.
They had some figures in the paper that really showed this in action.
Demonstrating the power of latent reasoning for problem solving.
They even ran experiments to see how well this Bolte algorithm works.
Like that bootstrapping on fixed data experiment.
To see the impact of self-generated latent thoughts.
And also continued bootstrapping for a more real-world feel.
Using that smaller tiny llama model.
And they tracked all sorts of metrics to evaluate the learning.
But importantly, they also looked at real-world task performance.
Like accuracy on those challenging math problems.
And they saw improvements across the board.
Showing that this latent thought approach really makes a difference.
This all fits into the bigger picture of AI research, right?
Definitely, especially with synthetic data.
But this approach is about augmenting data, not replacing it.
And the Bolte algorithm is quite self-supervised.
Making it a really interesting and self-contained system.
So the big picture is this potential for data-efficient AI.
By tapping into those hidden thought processes.
Which is crucial as data growth might not keep pace.
And this shows that AI can learn and improve in a more human-like way.
By thinking more deeply about the information.
It really does give us a lot to think about.
Absolutely.
And for anyone wanting to dive deeper into the details.
The paper and code are available online.
It's a fascinating look at the future of more efficient AI.
Thanks for joining us today.
And thank you to our listener for your great question. We hope that quick overview was helpful, and we appreciate you spending your time with us today.